So in this video, we are discussing the question number 2 of NBHM 2025. The question number 2, we need to check whether this limit do exist or not. If it do exist, then what is its value? So let's get started. So first we need to calculate the limit n tends to infinity. Integration 0 to 1 in x to the power n by 1 plus x dx. So for the purpose, I am doing a substitution. I am putting x equal to e to the power minus t by n, so that I can cancel this power n. So dx is equal to minus 1 by n e to the power minus t by n dt. Write down the integrand, integration 0 to 1 in x to the power n by 1 plus x dx. This is equal to, now if we put x equal to 0, then e to the power minus t by n is 0. Then the lower limit of t has to be infinity. If we put x equal to e to the power t minus t by n, this is equal to 1, then the upper limit of t has to be 0. So that becomes n. In place of x, I'm just putting its value e to the power minus t by n is whole to the power n by 1 plus e to the power minus t by n, and in place of dx I'm just writing minus 1 by n e to the power minus t by n dt. Right, so I can cancel this n with n, this n with this n. So now I can rearrange the limit with this negative symbol, and I can write integration 0 to infinity e to the power minus t by 1 plus e to the power minus t by n to the power minus t by n dt. Now I'm just writing as integration 0 to 1 gnt dt, where gnt is nothing but the integrand. Gnt is nothing but the integrand, which is equal to e to the power minus t by 1 plus e to the power minus t by n e to the power minus t by n. Okay. Now I will calculate the pointwise limit of gn. If now when t equal to 0, at that time the value of gnt is 1 by 1 plus 1 into 1, so that is nothing but 1 by 2. And if t is greater than 0, then gnt is equal to e to the power minus t by 1 plus e to the power minus t by n to the power minus t by n. Now if we calculate its limit, that would be, that tends to e to the power minus t. Now this portion is tends to 1, and that would be 1 plus 1, so that is e to the power minus t by 2 as n tends to infinity. In both of the cases, gnt, if we write gx is equal to e to the power minus t, and 0 less or equals to t is strictly less than infinity, then gnt converges to g pointwise, or gn converges to g pointwise on 0 infinity. Right, so we found out the pointwise limit of gn. Now note that this is gnt, right? E to the power minus x for any real number x is always more than 0, less than 1. This is always valid, right? So e to the power minus t is also less than 1 greater than 0, as well as e to the power minus t by n is also more less than 1 greater than 0. 1 plus 0 is less than 1 plus e to the power minus t by n is less than 2. Then I can write 1 by 2 is less than 1 by 1 plus e to the power minus t by n is less than 1. Now, if you multiply both sides by e to the power minus this value, so I can write 1 by 2. So I can write, pressing the red 5, I can write e to the power minus t by 1 plus to the power minus t by n into e to the power minus t by n is less than e to the power minus t by t, right? To the power 1 plus e to the power minus t. Now from that, what I can say, the integrand or the this is nothing but gnx gnt. So gnt is less than e to the power minus t for all t belongs to close 0 when infinity. Therefore gnt is dominated by the function e to the power minus t to the power minus t on 0 infinity. In this interval e to the power minus t is dominating gnt. Now if we calculate integration 0 to infinity e to the power minus t dt, let us check whether is that finite or not. So this is nothing but e to the power minus t, that from 0 to infinity. So that becoming e to the power minus 0 is infinity, e to the power minus infinity is 0, so that becoming 0 minus minus of minus 1, so 0 plus 1, so that gives you 1, which is less than infinity. Hence this e to the power minus 3 is integrable on 0 infinity. Therefore gnt is dominated by a integrable function e to the power minus t on the interval 0 infinity, and this gnt is pointwise convergent to g, and this gn is dominated by e to the power gnt is dominated by e to the power minus t on 0 infinity. Therefore we can use Lebesgue's dominated convergence theorem. By using Lebesgue dominated convergence theorem, I can interchange limit with the integration. So you can write limit n tends to infinity integration 0 to infinity gnx gnt dt, this is equal to integration 0 to infinity limit n tends to infinity gnt dt by dominated convergence theorem. So this is a very beautiful application of Lebesgue's dominated convergence theorem. Now we do know the limit integration 0 to infinity. We do know the limit. The limit is, you already have calculated. This is e to the power minus t by 2 dt, which is equal to minus e to the power minus t by 2 from infinity to 0. So that gives you 1 by. So therefore the limit of the given integrand is 1 by 2, which is our answer. So let us check the answer. So and the answer is 1 by 2, as you can see. So this is our question number. Thank you everyone.